even and add functions. We have here the definition. For even function, it should be symmetric with respect to the y-axis. So that's the symmetry there. Okay, so you're trying to plug in a negative x to your f of x, and then you will get the same equation. Again, plug in negative x, and then you will get the same equation. For the add function, you will get a negative when you plug in the negative x, and the graph should be symmetric with respect to the origin. Again, it's symmetric with respect to the origin. Okay, so let's have an example. Example, y is equal to x squared. So is this an even or an add function? So when you apply the rule here, you plug in negative x to your x here. When you take power of 2, it gives you the same equation. So that's what it means. You'll get a positive value. Same with your f of x. So it says exactly the same value. X squared, and you have x squared here. So it means this one is symmetrical to y-axis. So the parabola should be like this. And this is your y, this is your x. So it's symmetrical to the y-axis in this case. So let's try another example. If you have like y is equal to x cubed, you will plug in a negative x here. So plugging in a negative x to your x, it gives you a negative x times a negative x times a negative x, gives you a negative x cubed. So as you can see here, you will get a negative f of x. So your f of x actually is your y here, and that's exactly what we have here. So that's negative f of x. That's coming from the definition here at the bottom. It says a function f is an odd function if you have f of negative x is equal to a negative f of x. So this one is an odd function. Again, this is an odd function. The previous one was an even function. Okay, and what it looks like if you have a graph like this is a cubic curve, and the cubic curve is passing through the point of origin. Okay, so that would be the intersection point there. Again, that's the intersection point there, and it's symmetrical to the point of origin. So that's why this one is an odd function. Okay, so let's uh, get another example. So let me first make a quick review on what we did a while ago. Y is equal to x squared, or f of x is equal to x squared. That's a parabola. And the parabola actually is facing upward, and you have your y and x here, so it's symmetrical to your y-axis. So therefore, this is an even function. Okay, so the other one, it's y is equal to x cubed, and you have f of x there is equal to x cubed, and then you have the graph of a cubic curve. Okay, and it's symmetrical to the point of origin. So this one is an odd function. So now, if I have a function that is, let's say, x squared plus 1, and this is similar as saying f of x is equal to x squared plus 1, then the parabola is moved up 1 unit. We call that translation. So the parabola is at this point at the vertex 1 and still facing upward. So that is still symmetrical to y-axis. So this one's still an even function. You can also plug in the negative x there, and the equation doesn't change. So that was the rule. You plug in a negative x and then square that plus 1. It gives you the same equation anyway. So that's exactly the same equation as this one. So that's an even function. Okay. So now the technique here is following the definition or by just looking at the powers. So as you can see here, when we look at the power 2 here, that's even. That's why we have an even function. And you have a power of 3 there. That's an odd number. That's why we have an odd function here. And power of 2 on the third example, that is an even function because that's an even number. So by looking at the number itself, you can tell if that is even or an odd function. Okay, so aside from that definition, even function should be symmetrical to y. So that's the definition. You can see that the symmetry is at y-axis. The odd function should be symmetrical to your point of origin. So here's the point of origin. Symmetrical to the point of origin. Okay, so let's try another example. Let's say you have a mixed. You will have a function like f of x is equal to um, x squared plus x. Okay, so you have a power of an even, and here you have a power of a 1. So there's no power. That means that's a 1 here. So that's an odd number. So an odd and even number, obviously your answer would be neither. If you're going to be asked if this one is an even or an odd function. Okay, so similarly, if you have another example here, you're going to have, let's say, 2x cubed plus x squared. So still, it's a mixed. So you can see 3 as an odd number, 2 is an even number. So your answer would be neither. It's not an odd function. It's not also um, an even function. So it's not even, it's not odd. So the answer would be neither. Okay, that would be easy to tell, right? So now if I'm going to have another example here, f of x is equal to x cubed plus 1. Okay, remember, if I'm going to graph this, it will be a cubic curve. You have your y-x here, and 1 here is the translation, 1 unit up. So our curve here would be at 1. So you have 1 here for your y, and the cubic curve should be passing through there, like that one. So here's the um, y-intercept. It's at 1, not at 0, or not at the point of origin. So looking at the power, you're looking at power of 3, you're supposed to have an odd function here, but it doesn't conform with the definition. It should be symmetrical to the point of origin. So this is not symmetrical to the point of origin because this one is moved up 1 unit. So your answer here is neither also. Okay, so again, let me repeat that. Just look at the power. If the power are even powers, then that would be even function. If all are odd powers, then that would be an odd function. Plus, you have to note the symmetry, right? So even function has a symmetry on y-axis, an odd function has a symmetry on the point of origin. Okay, so one last example would be um, if you're looking at f of x is equal to x power of 4 plus x power of 2. So as you can see there, you have power of 4 and you have a power of 2. So if you have a power of 4 and power of 2, those are even powers. So the answer here would be not neither anymore. That would be even function. Okay, when you graph this, you can see that this one is symmetrical to the y-axis. Okay, if you want to check also by plugging in the negative x, you can actually do that also. That would be f of negative x is equal to negative x here, power of 4 plus negative x here, power of 2. So a power that has an even power, the negative here doesn't affect the term. So it should be a positive, right? Negative times a negative times a negative times a negative is a positive. So that should be x power of 4 plus same thing here. That's negative x times negative x is power 2. That's positive also. So as you can see, they are just the same. So to the original equation. So that's why our answer is an even function. Okay, the best way also, if you have a chance to graph these functions, you can see what we're trying to tell you in this presentation. So let me repeat that. Let's look at the powers. and even power should be an even function plus that should be symmetrical to the y axis, and for odd powers should be symmetrical to the point of origin to get an odd function. But if it's combination between odd and even numbers for the powers, then automatically that would be neither your answer, okay, or neither. So that's how you actually find even, odd, or neither.